Alright, recording is started. So welcome to Monday, March 7th. So we've got group set up today. Find a desk. We're gonna have a two name tag system. So some days we might be rows, some days we might be groups. I've always liked to do groups. We just haven't yet because COVID's been pretty bad last couple of years, but it looks like it's pretty well over. So yeah, we get to do a group project. So on the bottom name tag, when you're happy with the desk that you have, go ahead and write your name in there. Okay, so back on Friday, I told you guys some stuff about concrete. I told you guys about well graded versus uniform grade. So if you have well graded concrete, then you'll create stronger concrete because there's a higher proportion of rocks to cement. I told you guys about sieves. I told you guys about steel reinforced concrete and thermal expansion. There's some new posters hanging from the ceiling. So tell you guys about stress and strain. Right, stress is work per unit area, cross-section area. So that's pressure applied to solids. Strain is percent elongation. The ratio of those two, stress to strain, is called Young's modulus. That's a material property. Okay, so coefficient thermal expansion. There's some other posters related to thermodynamics and materials, which we're going to go into after spring break. Yeah, let's take a look at the schedule. So all this week we're doing toothpick bridges. Get you guys set up pretty soon here. In this week, spring break starts. We'll come back and we'll do more thermal materials. Next month we're doing electricity magnetism, then statistics, quantum mechanics, and that'll take us pretty well to the end of the semester. Yeah, I might slip in a couple other topics here and there, but we'll be about it. All right, so also I got a show and tell piece for you guys. So this is a piece of a concrete cylinder from my university days. So the way you can test straight up concrete, a pretty standard way is to create these cylinders. Well, this is part of one that's 4 inches diameter and 8 inches tall, and then you put it in a compressor, press until the thing bam breaks, which is related to this type for only for concrete. They don't really have like this whole bit. That's about all you get for concrete. Bam. Okay, so have you guys design and construct toothpick bridges with your groups today, with your teammates? Right, so your task is to span this 20-centimeter gap. Your budget is 100 toothpicks and Elmer's glue. That's get you guys some toothpicks. And we're going to test these out on Thursday. So the way we're going to do this is going to create a 20-centimeter gap. Now guys, 20-centimeter gap. Do you want your bridge to also be exactly 20 centimeters? No. No. Do you want shorter or longer? Yeah, let's go with longer. Yeah, have some overhang. So probably at least 22 centimeters, but 25 is probably safer. But more than 20, right? Otherwise, we'll turn to a raft. We're going to take this 8-centimeter diameter cylinder, like tape roll, put it on top, then put the grate tray on top of that, and just start loading lab weights. And whoever's bridge can hold the most weight will be the winner. Now, engineering consideration, I'm gonna steal part of this. Well, no, here, just in the abstract. Actually, let's steal my notes from last class. Okay. Well, let's take a look at that cross section. So this could be like a bridge tunnel, right? And you're going to drive through it, right? Driving through this bridge tunnel. Right? Now, what would be the stronger design for the cross section? Where the toothpicks are approximately horizontal like this, or they're like pretty well vertical like this? Let me see, show of hands. The answer is sort of given away here if you pay real close attention, but maybe they have the same load on them. One of these is going to break first, right? But the question is going to be, which one of these is the stronger design? The stronger design. Let me see, show hands. How many guys think that the design on the left is going to be the stronger design? How many guys think the design on the right is going to be the stronger design? Ooh, there's my winners right there. Yeah, it's my winners. Right, now, why would this be? Well, let's look into the trigonometry of this. So I've got some components drawn out, right? This also relates back to, there was a lab I had you guys do way a long time ago. It was a 10-part menu lab with a bunch of spring scales. You orient the spring scales bunch of different ways. How did the forces distribute? Now that was all tension because spring scales measure in tension. This is compression, but it's the same principles. Let's say I have a 20 Newton vertical load on each one of these, right? So the one where the toothpicks are and the materials are aligned vertically or pretty close to vertical, Well, each of these itself will carry approximately half the load because they might split 10 and 10 in the vertical component. And if they were exactly vertical, then it would be exactly 10 and 10. If they have a slight gradient to them from the vertical, then it might be like 11, 11, 12, 12, something like that. But it'd be pretty close to a 10, 10 split. Versus if this one, let's say this is like 60 degrees and 60 degrees. Now, you still have some of the vertical forces has to go to 0. So 20 newtons down, there must be 20 newtons up. You guys see it like 10 and 10, right? But that 10 and 10, remember, it's on line with the toothpicks. So if you do some trigonometry, if this is a 60-degree angle, this would be more like 20 and 20. You guys see that that force is each greater than that force? So that means that this one's going to break first, which means that this design on the right is the stronger design. Yeah, so if your materials are oriented more vertically, then they'll be able to carry more vertical load. That's a pretty big hint right there. I do that. All right, so another tip, there's some paper out on your desk. You can use that to sketch designs if you want, but also use that as a base just to do all your glue work on, because this project's going to take a few days. There's one aspect of this is there's a lot of patience with the glue, but done this project many times in the past. It's always a great project. So do all your work on a piece of paper. Then at the end of the class period, each class period, you can put your work back on one of those back lab desks, and then get it tomorrow, and then everything. Now the paper is not one of your structural materials, so you'll have to peel off the end. There's a few paper fibers that's okay, but it'll be good to not have a bunch of glue on the desk, and then also you can transport back and forth really easy, right? So I'm going to give you guys 100 toothpicks each, and you guys got the rest of the class period and a few days to work on this, and we'll test these on Thursday.